All right, so let's move into 5.5. So this is the integration by substitution. So the first objective on the final exam review said to find the indefinite integral using the general power rule. Okay. All right, so I'm taking a look at the ones they suggested, 13, 15, and 17. All right, and they're all kind of similar. So I'm just going to go ahead and do 15. All right, so with question number 15, we're trying to integrate x squared, 2x to the third minus 1 raised to the fourth power. All right, so that's the problem we're trying to do. All right, so I like to look at my inside function and take the derivative of it in my head, and I see 6x squared. All right, so that tells me that I like that because that is where that x squared is going to come from. And all I'm going to have to do is make an adjustment based on the new exponent and also based on what the constant is I get when I do the derivative of the inside. Okay. So we're going to use that mechanical process. We'll let u equal 2x to the third minus 1. We'll take the derivative of it with respect to x, and we would get 6x squared, and I'm writing that in differential form. Okay, so this 2x to the third minus 1 raised to the fourth power, and this x squared dx, I'm just rearranging a moment. So you see the x squared dx right next to one another. I don't see the 6 over on the left-hand side in the integration problem. So let me multiply by 1/6 to move that out of the way. So I wind up with 1/6 du equaling x squared dx. So that means in place of that, x squared dx, I can put 1/6 du. In place of this, I'm going to put the u to the fourth power and rewrite the problem so I could just use the general power rule. Okay. So I'm trying to integrate 1/6 u to the fourth du. Okay. So my new exponent would have to be a 5. So I need a 1/5 out in front. There was already a 1/6 out there, so I need to bring it along like I do for any constant. Throw a plus c on it, clean it up a little bit, and get x's back into the mix. So that would be 1/30, and the u is 2x to the third minus 1. So put that back in, and then add your plus c. And that would be okay. So would doing that to the fifth power all over 30 says the same thing. So, or either one of those is equally good. Okay. All right. Now another objective, or this objective, was also using the general power rule. The only reminder on that one I want to make is that when you go to rewrite, you need to remember that you can rewrite radicals using fractional exponents, and then you'll still do the same thing and yet let u equal t squared plus 2 and go from there. Okay. All right. So again, if you go to the e-text, you can work these additional problems out, and there's actually those things that say answer are pull down menus. After you try it, you could check your answers. Okay. All right. Now, the next objective says find the indefinite integral of a trig function. Okay. All right. So let's see here. So 35, okay, 36, and 39. Okay. Let's do a couple of these. Let's talk about 35. Do you see this would be your inside function, this pi x? If you did the derivative of it, you'd get pi. Okay. So that gives me a sense of where that's going to be. One of the things you have to worry about is whether you need to throw in a negative or not on your answer. Okay. Let me go ahead and do that one. So if we're integrating pi sine pi x dx, okay, you can still use your u substitution. So your u would be pi x. So du would equal pi dx, okay? And there's the pi dx. And so really I'm trying to integrate sine u du once I make my substitutions. So the hard part with this one is that would have had to come from a cosine. But when you think about doing the derivative of cosine, you know how it's going to produce a negative? You know how the derivative of cosine is negative sine u, and you don't have a negative? So you need to put one on it. Okay, so make sure you check that, whether you need to put a negative on it or not. This was number 35. Okay. All right, with 36, problem here is we have an inside function. I don't think I'll work this one out all the way. See, when you're reading these, that really means sine of 4x dx. So you can let u equal 4x, and then when you do the derivative, you'll get 4 dx. And you just have a dx, so you need to get the 4 out of the way. Okay. So I'm going to replace the 4x with u and the dx with 1/4 du, but I'm going to write the 1/4 here and the du there. So it's kind of organized, ready to go. Still haven't integrated. Now I'm going to integrate. Okay. And then let's take a look at 39, because it's kind of an interesting looking one when you first see it. Okay. All right. So I see a 1 over theta squared and then cosine 1 over theta. Okay. So I got to think about how this works. All right. So I'm guessing that this 1 over theta would be my u, my inside function. And remember that 1 over something is the same as that thing raised to the -1 power. Okay. So when I do the derivative of u with respect to theta, I'm looking at theta to the -1 power. That would be -1 theta to the -2 power d theta. And see how that would be -1 over theta squared? I like it. I like it. I see the 1 over theta squared piece of it. Okay, so I'm going to make a substitution. Let me rewrite this just slightly so you see it. Here's my 1 over theta. That was just a squiggle, not a 2. Okay, and then let me put the 1 over theta squared closer to the d theta. Make sure that you notice. See how I have that, except for I have that extra little negative that I don't want. So I'm going to multiply by a negative or divide by a negative to get the 1 over theta squared d theta by itself. And so then in place of that, I'm going to put a negative du. So I'm going to put a negative du, but I like my constants to be in front. So let me go ahead and, oops, I forgot to change that. Let me go ahead and put that in front. And then in place of the 1 over theta, we'll put our u. So that's what I'm trying to integrate. Okay. So now I have to think about integrating that. So to wind up getting cosine after you do the derivative, it would have to come from the sine function. But when you do the derivative of sine, you just get cosine. So if you need a negative there, you're going to need a negative on it. Then throw a plus c. Okay, oops, I forgot to put the, I just thinking about this when I realized I forgot to put the u back in. So then I would get negative sine 1 over theta plus c as my final answer. And on this one, that what I had circled was not my final answer. I forgot to replace my u. So that would be negative cosine pi x, okay, plus c would be my final answer. And that's one you might have gotten just without doing, by doing pattern recognition instead of the u substitution. Right? All right, another one in 5.5 that you tackled was finding the indefinite integral of an exponential function. All right, so 45 and 46. 46 looks harder. Let's do that one together. So I'm integrating x plus 1 e to the x squared plus 2x dx. This is either exactly or very familiar to one we did in class. It just feels just like it. Okay, so we're going to let u equal x squared plus 2x, which means du would equal 2x plus 2, okay, with dx at the end. All right, so I can kind of see where we're going with some of this. I'm going to have a u where this x squared plus 2x is in a moment. And then this x plus 1 is going to go with that dx and get replaced. But you don't really see that right here because it's camouflaged a little. If I factor a 2 out, there's an x plus 1 left. So here's what I'm trying to substitute in for. So I'm going to move the 2 out of the way by multiplying both sides by 1/2. And then in place of all of this right here, I can put a 1/2 du. So let me put the constant out in front. And this e is not with the 2. It's next to that or up on top with a u. And then in place of x plus 1 dx, the rest of it, I put a 1/2 out in front already. I'd need the du. But I haven't integrated, so keep the integration symbol. And then this is not a power function, so do not think that you need to do e to the u plus 1. It's just going to be an e to the u. Okay. Bring the constant along, add c, and replace the u, and make sure that you realize it's next to or on top. Replace the u with x squared plus 2x, and don't forget the plus c. And that's the same as e to the x squared plus 2x, all divided by 2, if that makes it more clear for you. And then I like to check them. I haven't been showing you that, so let's do a check on that. Take what you think your answer is and do the derivative of it. So wouldn't you bring the 1/2 down? Wouldn't you do e to the x squared plus 2x and then multiply by the derivative of that exponent, which would be 2x plus 2, and the derivative of c would be 0. All right, and then this 2x plus 2, when I multiply that by 1/2, wouldn't that be e to the x squared plus 2x? When I take this right here, which should have been in parentheses, times the 1/2, wouldn't I get just 1/2 times 2x would be x, 1/2 times 2 would be 1. And then, yeah, that's what I was supposed to have, okay? So I wind up getting the x plus 1. I just am not going to take the time to write it out in front, but it checks, okay? All right, so that's 5-5.